pretty much with your summaries, yeah? Okay. I feel like I can't hear myself. All right. Today's rules of exponents with rational exponents. Rules of exponents with rational exponents. In other words, I'm going to add to what I did last week. So we're going to do stuff from last week, but we're going to add to it a little bit differently. What does it mean to be a rational exponent? What's a rational exponent? It's a fraction. The essential question is almost complete at the end. How do I evaluate using the properties of exponents with rational exponents? I had a little bit of a brain block. So how do I evaluate? Using the properties of exponents with rational exponents. Bless you. All right, there's no other way to go but to jump right in. We're going to simplify the expression. No other way but to jump right in. All right, so let's start off. We have fractional exponents. So we have 7 to the 1/9 times 7 to the 1/2 power. 7 to the 1/9 times 7 to the 1/2 power. Alrighty. Excuse me. All right, so we're going to draw in our little, those when you watch like cartoons and you get like a little bubble in their head, it's like their thinking bubble. We're going to go do that over here on the side. We're going to have our thinking bubble. And we are going to write 7 squared times 7 to the 3rd. Because doesn't this look very similar to this, minus that it has fractions, right? Looks identical, kind of the same. Same properties, same idea. So we're going to do it over here on the side to see what we actually do. So we have 7 squared times 7 to the 3rd. What does it mean to be 7 squared times 7 to the 3rd? How many 7s do you have here? 2. And how many do you have here? 3. And if I count them up, I get 7 to what power? To the 5th, right? So what can I say was the rule with the 2 and the 3? You added them, right? So in our head, we added them. Now, last week, did I want you to add? Not necessarily. Because what happens is some of you start to add and you get things wrong. So we didn't write it out last week as the rule, but it is the rule. Now, do I have to memorize the rule? Not necessarily, but I do need to know it when I'm dealing with the fractions, okay? I don't think the fractionals are like this on your test. I think on the test it's going to be more of like what we did yesterday, all right? Your test is 1 week from tomorrow. So you have 2 plus 3, which is 5. True? Fair statement? So over here, we now know that the rule is to do what with the exponents? Add them. Good. So we're going to add the exponents. Now, this is where your knowledge of fractions, or lack thereof, will either determine if you understand today's lesson or not. Okay? If you understand fractions, today's easy. If you don't understand fractions, it's going to be difficult. So what this says is that you have 7, and you're adding 1/9 plus 1/2. Yes? Isn't that the same thing as over here? True statement? All right, so we're going to do this. Now, what is the rule when adding fractions? Can you just add them? What do they have to have? A what? Same denominator. So they must have a common denominator. Where is the denominator located? Bottom? So it's the bottom number. So we must have a common denominator, which is the bottom number. True? Okay. So I'm going to take these over here to the side so we can actually do that. So I'm going to go ahead and add 1/9 and 1/2. When I add 1/9 and 1/2, what's your denominator that's going to make them the same? What's your common denominator? 18. So what do you need to multiply the first one by? And the second one? Good. Okay? So let's multiply. What's 2 times 1? Over. Good. Plus 9 over. Good. Which equals 11 over 18. Remember, you don't add denominators, you just bring it over. Yes? Ladies and gentlemen, I have an answer. My answer is 7 to the 11/18. Be careful. Some of you are writing your fractions and they don't look like fractions. They don't look like exponents, first of all. Your exponent needs to be up at the top, it needs to be smaller than the base. Okay? Make sure I can tell that it's an exponent and not a number next to it. We good? Make it look like an exponent, not a mixed number. Okay? So you're going to do one by yourself. Go ahead and add x to the 1/2 times x to the 1/5. X to the 1/2 times x to the 1/5. Check with your neighbor, that's why you're next to them. Jaden, I don't know why you're on your phone. I hear that too? Do we have an answer? Yeah? Okay. What's the rule? Add the exponents? Yeah, that's right. 1/2 plus what? 1/5. What's your common denominator? So what do you multiply the first one by? And the second one? And you get what? 5/10 plus 2/10, which is 7/10. So your answer is x to the 7/10. Yes? Who's right? Wonderful. Let's go on to the next one. That's B. C. X to the third to the 1/9 power. X to the third to the 1/9 power. All right. Back to our remember when bubble. Last week, we did x to the third to the second power, right? Fair statement? All right, what did it mean to be x to the third to the second power? X to the third times, you write it 2 times. So it said x to the third times x to the third, yes? Okay. And then you're going back to the rule up above, and we knew that 3 and 3 is how many? X to the, oh, never mind. Let's do this slow. How many x's are here? And how many here? For a total of how many? How many? Oh, there we go. That's a better answer. So, question to you is this. How do I go from here to here? We multiplied. So, in our brains, we're saying x to the 3 times 2. Yes? That's what we're saying. I just kind of squeezed it in there. So, x to the 3 times 2. So, over here, we're going to go ahead and say multiply the exponents. So what are the exponents I'm going to multiply? 3 and 1/9. Okay. So here's 3 times 1/9. How do you multiply fractions? What's the 3 missing? Put it over 1. How do you multiply a fraction? Where? Go across. So 3 times 1. And 1 times 9. And do I get to leave it like that? No, I'm going to say you have to reduce. What are you going to divide by? 3. So 3 divided by 3 is what? 1/3. So my answer is x to the 1/3. Some of you are looking at me like I'm crazy because fractions are your enemy. Get over it. You need to get over it because you're going to deal with fractions all year long. Especially when I go to graph. Okay, let's keep it going. Right? Don't I do fractions like all year? Yeah, huh? For sure. Especially when I do graphing and your parabola. There's a fractional. Yeah. Well, let it around D. I'm going to switch it up. 6 to the 1/2 times 2. Go. Who has an answer? Why don't you have an answer? You think you do? Why? You what? I'm a little confused. All right. What is the property you're doing with 1/2 and 2? You're multiplying. So you're going to go take 1/2 and multiply by 2. What goes underneath your 2? 1. Multiply straight across. What do you get? 2 over 2, which is what? 1. So you get 6 to the first. You do not need to write the first, but I did in terms of this. Okay? Who has it right? Good. Why? Well, yeah. Okay. I'm going to talk about this really quick for a second, because I'm going to think of it in terms of a different thing really quick. So, a little bit of a remember when, but not too big. Yesterday, yes? What does it mean to be the 1/2 power? What does it mean to be 6 to the 1/2 power? Oop, that's a 1/2 power. That's not big. I don't like it. 1/2. That's better. What does it mean to be the 1/2 power? Think of yesterday. What's your 1? Your power. What's your 2? Your root. Can I rewrite this? Yes. Okay, so in the radical is the root is and I don't need the first power, correct? Yeah? Make sense? Okay, now I'm going to kind of show, I need to show this for a second, because this is going to appear multiple times this year. If I square it, so now let's pretend we have this squared, yes? If I square it, I just did this rule over here. What did I get? I just got what? 6. So now I know that when I have a squared and a square root, my answer is just the number inside. Yeah, it'll work for anything. So in other words, what Alyssa's saying is, let's just say you have a cube root. The number outside would have to be what? A 3 for it to just give you the inside. If you had a 4th root, the power needs to be a 4 for you to give you just a number on the inside. If it's not exactly the same, is it going to cancel? No. It has to be exactly the same for it to cancel. Do you understand? So you need to know, we're going to just write it somewhere like at the top, that when you have a square root, and you square it, you're just going to get the number inside. Yes, it works for a cube root also, but it has to be cubed for it to give you the number inside. Okay? This is going to reappear throughout the year. And then I'm going to say, hey, remember when? And you should just know that they cancel each other out. Got it? Or I'm going to go back to doing this example on the board every single time. Make sense? All right, let's do another one. We have, let's switch up the base. 5 to the 1/2 times 4 to the 1/3 all to the second power. 5 to the 1/2 times 4 to the 1/3, all to the second power. What does that mean? What does it mean? I know what it means. I'm not going to tell you. What does it mean? You what? I'm not quite understanding. So what would you write? Okay, that is not correct because are they the same base? Are the 5 and the 4 the same base? Then you can't do that. Good guess, though. You can't add these together because they're not the same base. Okay? What else? You what? So what do you want to write?
Well, we just did the first, so we know it's 5, and then 1 over 3, and then 2.
You can do that. What else? Question. If I gave you x squared y cubed to the second power, what would you do? You'd write it 2 times. You would write x squared y cubed and x squared y cubed, right? Yeah? And then what would you do then? Add the x's, right? Put your x's together. So how many x's did you have? 4. And how many y's? Wonderful. Can I do the same thing over here? Yeah. So I see it's squared. Alyssa, you're right, though. You can do that rule. So what do you want to do? Write it how many times? Twice. Okay. So 5 to the 1/2 times 4 to the 1/3 times 5 to the 1/2 times 4 to the 1/3. Yes? Okay. Can I rewrite it just to be a little bit nicer? 5 to the 1/2 times 5 to the 1/2. And then, I don't want that color. 4 to the 1/3 and 4 to the 1/3. I just rewrote it so I could put them together. Fair enough? Okay. What's the property with the exponents now? What? Combine them. So in other words, what's the word for combine? Add. So can you add 1/2 and 1/2? Yes. Okay. It's what? Oh, okay. And what's 1/3 and 1/3? There you go. What about them? You can't. Did we add them on the other side when I had 7 and 7? That's why. Okay. Last one. I'm missing a property. 5 over 5 to the 2/3. 5 over 5 to the 2/3. Ready? Okay. My little think bubbles. Okay, if I have 5 to the 5th power over 5 squared. 5 to the 5th power over 5 squared. How many 5s did you have on the top? 5. How many 5s on the bottom? 2. What did we do with them? Why can you cross them out? Because you divide, thank you. Because we're dividing. And what were we left with as our answer? 5 to the 3rd power. Yes? There? Remember? All right. So my question to you is this. What's the rule between the exponents? It's not division. You can't divide 5 and 2 and get 3. Subtraction. So the rule is you're subtracting the exponents, yes? So what do you think the rule is over here? Subtraction. Subtract the exponents. Dakota, are you writing or are you looking outside? Dakota, writing? So what are my exponents? What's the first exponent? 1. Why is it 1? Because there's nothing there, so it's always a 1. So we're subtracting 1 minus what? 2/3. Can you subtract those? Most of you can't, some of you can. All right, we're going to go back to third grade. Ready? Because you guys don't have a good grasp of fractions as a whole. This is one whole, yes? We have it broken up into thirds. This is 1/3, this is 1/3, this is 1/3. Altogether, that makes a whole, yes? Okay, we are taking away how many thirds? 2. What's left? 1/3. If you need to find a common denominator, you can. I'll show you. This becomes 1/1. This becomes 2/3. If it was me, I would just subtract it, but for some of you, it's not easy. So then this is 3/3 minus 2/3 is still 1/3. Okay? How many of you remember seeing this like in third grade? Good. You didn't? Ever? Maybe? Or you just don't remember? I do this with my niece all the time, guys. And then I go like this, and we break this one into 4s. And we compare, if we take a half here, which one has more. This is my life. Math all day. All right, we good? So what's our answer? 5 to what power? 1/3. Beautiful. Questions? It's all fractions. Fraction all day long. Yeah? If you don't understand the fractions, that's where you're going to get stuck. Okay, you have homework. It is in the Algebra 2 book. Lucky you. Page 424. It's also on the board back there, over there. 3, 4, 8, 9. If you never checked out your book, that's not good. 15 to 17. 24 to 27. 43 to 46. And 52 to 55. It's a little over, I know it's 2 pages because I know it's more than 16 problems. It's about 20 or so. The only thing I'm going to remind you of is you will have to combine radicals. So we did that last week. Just remember that. It's not too crazy. It's pretty easy. I think there's some review, that's why. All right. You are partnered together. Do you each need a book? No. One book in the middle should be fine. Yes? Okay. First period could not figure that out for the life of them. And then they're trying to squeeze it in. All right, so you need one book per group or partner. I put the remind code back on the board because some of you are not in, and then when you go to fail and you say, well, she wasn't there to ask for help. Felix, it's on the board. Yeah. I have to send you to Morales, though. No.